Welcome back, students. Today we are going to discuss the second law of motion given by Newton. In first law, we have discussed that the first law of motion defines the force. Something should be given from outside to change the state of motion, and that something has been defined as force. Now the question is, how much force should be applied? In which direction the force should be applied? At which point the force should be applied? For getting the answer of all these questions, first we need to think about few situations which gives us the new quantity in science, in physics, which we are defining as momentum. Imagine the situation: a truck is at rest. Do we need to pay attention on that? Do we need to worry about that? But if the truck is moving with a very slow speed, are we supposed to pay attention? Take one more example. In a fair, you all had enjoyed that shooting of the balloon. Do you know that what is used as bullet in that? It's green gram. How small it is. Try to throw it by your hand and try to burst the balloon. Will the balloon burst? No. Then if we are firing that with gun with same green gram, which quantity has been changed in physics? Just think. Still take one more example, that two objects, two vehicles are coming in front of you. The scooter with safer slow speed and the bicycle with full speed. Another example, that in a tennis court audience, the ball goes to the audience. Does it make any hurt? Now in the audience of cricket match, the cricket ball, the season ball is going in audience. Does that hurt anyone? Can it hurt? Just think of all these situations, and two things we are getting. Whenever we are applying force, only mass is not important, only velocity is not important. Just think, recall all that examples which we had discussed just now. But the product of both the quantities, that is mass and velocity, that gives us the measurement of the force. That means how much force we are supposed to apply to change the state of motion of the object. And that's how we are getting one new quantity in physics, that is, we are defining as momentum. So Momentum of the object is the product of mass and velocity. Momentum is symbolized as P. So the formula for the momentum we are getting as P equals to m into V. And from the formula, if we are writing the unit for momentum, then for mass we are having the standard unit as kg, and for velocity we are having meter per second. So the unit of momentum becomes kg into meter per second. Now we want to get the Newton's second law, and we are having few algebraical steps, the derivation as we have done earlier in motion also. How this momentum is going to help us, or how we are supposed to think on that. Imagine the situation that a car with failed battery, will it run? Will it go? No. But we have to push it. 2 or 3 persons can push the car. Once we are pushing them, does it enough? No. 2-3 persons are pushing the car for 1-3 minutes. Then gradually the car starts moving itself, and then it increases its speed. So over here, with momentum, the change in momentum is also important, and whenever we are saying the word change, it is always related with the quantity time. So the Newton's second law states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. The word proportional, that means if we are increasing the force, acceleration, velocity will increase. If we are reducing, we are decreasing the force, the velocity will decrease. So the proportional, that means if one quantity is increasing, another is increasing. If one quantity is decreasing, another is also decreasing. And the sign for proportional, we are showing it with this. Remember this sign of proportionality, just like alpha. Then the time rate of change of momentum. So momentum, that means mass of the object always remains constant. But the velocity, earlier the car was at rest, that means the velocity of the object is 0. And then it increases its velocity. So the final velocity we can write as V. In the answer of derivation, always state the law very first. Then describe the situation with the proper symbols. That means suppose the object of mass m is moving on a straight line path with initial velocity u and final velocity v for the time t. And that's how it will get the accelerated motion. So this acceleration is directly proportional to the applied unbalanced force. Now we are writing the mathematical steps for that, and we will start with the change in momentum is proportional to the P2 minus P1, that is final momentum minus initial momentum. P2 that is related with final velocity, so we are getting the expression mv minus mu. We can take the m common from that, so we are getting m into v minus u. Now as I said that when we are using the word the rate of change of momentum, as the word rate of momentum is added, we are supposed to write m into v minus u by t, and that is directly proportional to the applied force. So we are getting applied force F is proportional to m into v minus u by t. If I want to remove this proportionality sign, I have to add the constant, which is we are writing as k. So we are getting the expression as F equals to k into ma. And that states that if I want to apply 1 Newton force, then the mass of the object will become 1 kg and the acceleration will become 1 meter per second square. So here we have seen that we are having the formula F equals to k into ma. When we are having the mass 1 kg and we want to accelerate that 1 kg mass by 1 meter per second square acceleration, whatever the force we are applying, that is known as 1 Newton force. That is the SI unit for the force. The CGS unit for the same is written in the memory of the scientist Dyne. So Newton and Dyne both are the units of the force. This formula proves Newton's first law also. If I am not applying any force, so this F will be 0, and in that situation remaining all are the constants, so V minus U is equals to 0. And that means we can write V equals to U. So if there is no external unbalanced force, then object will continue in its uniform motion. That means it is not changing its state of motion. So we conclude that Newton's first law defines the force and Newton's second law gives the magnitude of the force, that means how much force we have to apply, that we can know from the Newton's second law. In practical life we are having lots of applications of Newton's second law, especially in the field of sports. Whenever the fielder is trying to catch the ball in cricket match, normally he moves backward, and during this time the velocity of the ball is reducing, it is decreasing, so the chances of harm, injury is decreasing. Likewise, for the high jump or for the long jump, the athlete is taking some running, and after that they are going for the high jump or for the long jump, so they are actually taking more time to increase their momentum, and that gives them help for that jumping. In the karate, the player is first taking their hand 2 or 3 times back, and then they are applying force on the tiles or on the ice or any other bricks or anything else. So basically, for giving the force, we need to think about the change in the momentum. In our next video, we will discuss the beautiful third law of motion, that action and reaction are always equal and opposite in the direction. Thank you.